AI, machine learning, a term that has become part of our everyday vocabulary. The evolution has begun, and there's no better time for tech enthusiasts like you set out on a pursuit to learn this technology. This is an entire series that will train you to developing your very own machine learning models from start to finish. We're going to be looking into practical topics in machine learning, such as data preprocessing, regression, clustering, classification, association rule learning, and reinforcement learning. Now, what are the requirements for this course? Basic knowledge of Python programming, use of mathematics, and the use of internet. Now, the coding materials used in each episode for this course will be linked in a GitHub repo. Feel free to access the link to the GitHub repo in the description below. This entire course was sponsored by Smiles Tech, the platform invested into tech-related products, news, and projects. Be sure to subscribe to their platforms on YouTube and Facebook. So, what are you waiting for? Let me see you in the machine learning series.
Now we are going to be setting up our code environments to help us to program and train our machine. First of all, there are three basic environments which I want us to understand about. First, Jupyter Notebook, then which is the same for Ubuntu and for Windows, but the setup is different, which I'll be showing in this tutorial. And we have our Google Colab. Now for Ubuntu, that is for those on Linux, I'm going to show you how it's done. First of all, with your internet connection, you will have to go open your terminal. As you can see on my screen, I'll just type pip install. Now you have to install pip. Pip is the package installer for Python. Pip install Jupyter Notebook. Then you hit enter. So I have that already on my machine. So that's why it's saying requirement already satisfied. So that is it. Now, if I go to my search, you see what Jupyter Notebook here. So I'm going to click Jupyter Notebook, and it's going to open a terminal for me that will take me into Jupyter Notebook. Now I'm going to just show you how it's being used. Let me just open some. Now this is just the interface for our Jupyter Notebook. So now, if, for example, we want to install a package on the Jupyter Notebook, what you just do is just pip install, let me say scikit-learn, because that's what we are going to be using throughout this tutorial. And we'll run this cell. How to run it? We'll click this play button here, or we'll go to run and click on run selected cell. But for a shortcut, you just hold down shift and enter. It's going to install it. Now I already have scikit-learn on my machine, so that's why it's saying requirement already satisfied. Then perhaps you want to import scikit-learn. You just have to just type import sklearn, and this will import sklearn for you. Now it shows that there was no error and the importation was successful. So these are some of the basic things you need to know, like you can add cell below, you can add cell above, yeah, as you can see here. So you can save your file, save all. Just once you get to open your Jupyter Notebook as a computer genius, you can be able to just go around it and everything. So now I'm going to show you how to install for Windows. Now, because of the constraint, in the sense that my system is Linux, I'm going to be passing this link of this description on our GitHub page so that you will see it and you will just follow the tutorials for Windows users, and you now get to understand, know how you can install it on your system, getting started with Anaconda and Python on Windows. So I'm going to share the link with you on our GitHub page. So it's not a problem, just follow the tutorial and get used to it. Then another one, which is our Google Colab. Google Colab is just like you're having a Jupyter Notebook, but now it's online. It's not on your system. It's not local. It's online now. It's provided by Google. Google is just a notebook, an IPython notebook. So you have to sign up here, and I've already signed up, so I wouldn't be passing through all those rigorous process. Actually, it's very simple. If you just click sign up, you need to have a Google account for you to access it. Then this is an example of a a Google Colab interface. First, you need to connect your runtime. So you just choose a runtime here. By default, you have a runtime. So if you just hit this connect runtime, it connects for you. Then the same code. The difference is that uh, unable to connect to runtime is just because my network is not very stable here. But it should connect with a stable network. So the difference between Google Colab and Jupyter Notebook is they are not very much different. But what we can say about it is that you have your runtime. You can increase your runtime, and if perhaps what you want to work with is too large and you can exceed your runtime, you can get to buy more paid version, which if you try to change your runtime, you see purchase additional compute units. So it helps you to purchase additional compute units. Just the same way you run it on your Jupyter Notebook. Guys, that is how you can run it here on your Google Colab. So it doesn't really need any further, just get used to it. So, but you need to be connected to the internet for you to access this. Okay. So now that comes to the end of our out on the required knowledge, the necessary things you need to set up your environment. Okay. For this for this tutorial, that is what we've discussed. Now we'll go to the next tutorial and you should sit tight because it's going to be wonderful. Now we are going to be setting up our code environments to help us to program and train our machine. First of all, there are three basic environments which I want us to understand about. First, Jupyter Notebook, then which is the same for Ubuntu and for Windows, but the setup is different, which I'll be showing in this tutorial. Then we have our Google Colab. Now for Ubuntu, that is for those on Linux, I'm going to show you how it's done. First of all, with your internet connection, you will have to go open your terminal. As you can see on my screen, I'll just type pip install. Now you have to install pip. Pip is the package installer for Python. Pip install Jupyter Notebook. Then you hit enter. So I have that already on my machine. So that's why it's saying requirement already satisfied. So that is it. Now, if I go to my search, you see what Jupyter Notebook here. So I'm going to click Jupyter Notebook, and it's going to open a terminal for me that will take me into Jupyter Notebook. Now I'm going to just show you how it's being used. Let me just open some. Now this is just the interface for our Jupyter Notebook. So now, if, for example, we want to install a package on the Jupyter Notebook, what you just do is just pip install, let me say scikit-learn, because that's what we are going to be using throughout this tutorial. And we'll run this cell. How to run it? We'll click this play button here, or we'll go to run and click on run selected cell. But for a shortcut, you just hold down shift and enter. It's going to install it. Now I already have scikit-learn on my machine, so that's why it's saying requirement already satisfied. Then perhaps you want to import scikit-learn, you just have to just type import sklearn, and this will import sklearn for you. Now it showed that there was no error and the importation was successful. So these are some of the basic things you need to know, like you can add cell below, you can add cell above, yeah, as you can see here. So you can save your file, save all. Just once you get to open your Jupyter Notebook as a computer genius, you can be able to just go around it and everything. So now I'm going to show you how to install for Windows. Now, because of the constraint in the sense that my system is Linux, I'm going to be passing this link of this description on our GitHub page so that you will see it and you will follow the tutorials for Windows users, and you now get to understand, know how you can install it on your system. Getting started with Anaconda and Python on Windows. So I'm going to share the link with you on our GitHub page. So it's not a problem. Just follow the tutorial and get used to it. Then another one, which is our Google Colab. Google Colab is just like you're having a Jupyter notebook, but now it's online. It's not on your system. It's not local. It's online now. It's provided by Google. Google is just a notebook, an IPython notebook. So you have to sign up here. And I've already signed up, so I wouldn't be passing through all those rigorous process. Actually, it's very simple. If you just click sign up, you need to have a Google account for you to access it. Then this is an example of a a Google Colab interface. First, you need to connect your runtime. So you just choose a runtime here. By default, you have a runtime. So if you just hit this connect runtime, it connects for you. Then the same code. The difference is that unable to connect to runtime is just because my network is not very stable here. But it should connect with a stable network. So the difference between Google Colab and Jupyter Notebook is they are not very much different. But what we can say about it is that you have your runtime. You can increase your runtime, and then if perhaps what you want to work with is too large and you can exceed your runtime, you can get to buy more paid version, which if you try to change your runtime, you see purchase additional compute units. So it helps you to purchase additional compute units. Just the same way you run it on your Jupyter Notebook. Guys, that is how you can run it here on your Google Colab. So it doesn't really need uh, any further. Just get used to it. So, but you need to be connected to the internet for you to access this. Okay. So now that comes to the end of our part on the required knowledge, the necessary things you need to set up your environment. Okay. For this and for this tutorial, that is what we've discussed. Now we'll go to the next tutorial and you should sit tight because it's going to be wonderful. Hello guys, welcome to this practical series on machine learning. You might be wondering what is machine learning. Well, machine learning is the ability to write algorithm that teaches your machine, actually a computer, what and how to recognize patterns in your data that is being able to learn from it. In this course, we are going to look at the practical aspect of machine learning with Python programming, which consists of data preprocessing, modeling, and evaluation. Data preprocessing, which consists of importing your data, cleaning your data, splitting your data into training set and test sets. Then the modeling, which is the fun part, is building a model, basically like training your algorithm. Then evaluation, where we make verdicts and evaluate performance. The history, the brief history of machine learning. First of all, the concept and idea of machine learning started when a British mathematician and logician named Alan Turing in 1950 just asked the question, can machine think? Alan Turing's work brought about the groundwork for artificial intelligence. And in 1952, Otto Samuel developed a game. It's very interesting that machines could play games. And it's what it does is that it learns from its previous patterns and predictions and its previous mistakes and improves. In the 1960s, Frank Rosenblatt came up with an idea, an algorithm called the perceptrons. And the idea is that it mimics the human brain, the neurons that connect with the human brain. But it faced the challenge of computational powers in the sense that it computes too much of data and it takes a long while to do that. So, and it also faced skepticism and funding costs. But that was not the end. Enthusiasts like Geoffrey Hilton, who is now the father of artificial neural network, and Jan LeCun developed and they went further into it and brought out what we know as neural network, artificial neural network. There was a big breakthrough in machine learning, and when uh, companies like IBM and Google, brought out things like Deep Blue in the 1970s, 1990, in 1997, that beat the world's best champion of chess. Can you imagine that? And also, Google used it for their search engines. And in these search engines, it's being able to rate websites based on their rankings. And then there are several other things you could do, like speech recognition, and it's helped in the computational powers of machine learning. There was a development actually. So that was how it went up from going from Otto Samuel to Frank Rosenblatt. And now we have it in the early 90s. Now, machine learning evolved and became even much better from 2010 when there was the deep learning. Deep learning is a subset of machine learning that does with natural language processing, speech recognition, image recognition, and it was such a wonderful thing that you could have self-driving cars. You could interpret languages from their original forms into things that can be understood generally. Like if you go on Google, you can see translations from one language to the other. And this happened from 2010 when deep learning started. And you can also see a machine learning model was developed in 2016 that could play Go, which defeated the world best champion. The future is bright in conclusion with machine learning, which is the basis of what we know as AI, artificial intelligence, from ChatGPT, from Gemini, from Bard, and have you ever wondered why search patterns on Netflix always give you recommend video based on your past searches, and also the same thing with YouTube. Also, when you go on Google, does the same thing with natural language processing, self-driving cars, and all the fun and interesting things you can ever see in machine learning. Stay tuned in this course, and that is the series of what we are going to do. Now, in this course, we are going to look at types of machine learning. And although there are various types of machine learning, but we are going to look at just two types of machine learning: supervised learning and unsupervised learning. In supervised learning, have you ever wondered how to teach a young child how to recognize things? For example, how to recognize a dog. Say a dog has a tail, a dog has long ears, and a dog can bark. That child is being able to recognize it because you gave that child an answer to a question. So that is what unsupervised learning does. You give the data, you give the machine a question and an answer. So when it finds such question, it's being able to answer it based on the answer you gave it. So that is supervised learning. Unsupervised learning is basically what we do in classifications, and you don't give an answer to a machine in unsupervised learning. You just ask it a question, and the machine is being able to choose randomly based on similarities between data and patterns. If it finds it is being able to classify it, just like giving a child, a basket full of fruits and telling the child to classify it. So that child will basically do it based on the shape, the color, and somewhat the test for people that can test things. Then there are some real world applications of machine learning, and it's very exciting that we have them around which we can cite from. You have things like ChatGPT, you have things like Bard, Gemini that have been brought out. And have you ever wondered on Amazon, for example, as an online store that gives you recommendation based on past purchases? We see it in self-driving cars. We see it in medical diagnosis, in finding faults, in checking for fraudulent activities in banking sectors, and also in our cryptocurrencies like Bitcoin, Forex trading. There are chatbots, there are, let me say, prediction models that have been built to predict the stock of the market. And these are the very wonderful things that AI does, and which we are going to be looking at, be delving into in this series of course. So that is the end of this episode. Hello, welcome to this second episode on our machine learning series. we are going to be handling data preprocessing. And in this first part of data preprocessing, we are going to be looking at installing the required Python libraries for our data preprocessing. Then we'll be importing these already installed libraries. Then we'll now have to import the data from the data set, and we'll be taking care of missing data from this data set. At the end of this course, you'll be able to know how to import the necessary required data and libraries for this machine learning, and you'll be able to use it to train your model. Now, let's get our hands dirty on our data preprocessing practical. First, you need to install the required Python libraries. And to do that, if you go to your machine, we are going to create a new cell. And under this cell, you can see it's written code here. So you should make sure of that. Then to install this required library, you give in a hyphen, then pip, which is the Python package installer. Pip install. We are going to install some libraries which we need for this machine learning course, data preprocessing. First one is NumPy. NumPy is also known as numeric Python. Then I don't want it to be so much code. I just want to run this line of code once. So because I want to install several packages once, I just write it in just one line. To do that, what you need to do is to type pip install numpy, then a space, the next library, pandas, and another space, next library, which is scikit-learn. Remember your hyphen in scikit-learn. Then we're going to install matplotlib. So if I run this cell, as you are seeing here on the tab bar, or I click on run, it runs selected cell. Look at the keyboard shortcut, shift enter is the keyboard shortcut. So for every cell, if I click shift enter, it runs that cell. Let's hit that on your keyboard. Once I hit that, we are saying that requirement is already satisfied for my own system. Now for yours, if it's not yet installed, make sure you're connected to the internet for you to install it properly. Then what you are going to be seeing is that you are going to be seeing a progress bar to show you that you are installing the libraries on your device. Then once that is installed, what we are going to do next is that we are going to import the libraries. So what we'll create a cell underneath this for importing the libraries. And what libraries do we need to import? We need to import our NumPy, which we've installed. We import it as MP. Then we'll import pandas as PD. Then we'll have to import matplotlib, which is for data visualization, .pyplot as PLT. So once you run this cell, what it does is that it imports, just like a preprocessor directive. It imports all these dependencies, all these libraries into our system for us to use it. Now the next thing we are going to be looking at is to import the data set. And before we go into importing the data set, there are some few things I'll need you to understand about the data set. Before you use any data, you must be able to know what the data is all about. You must be able to read data. You must be able to understand the data. So now let's go into this data. We are under here data.csv. We have to click it so that we'll see what the data is all about. Now it's a CSV file. CSV file means comma separated values. Now in this data we have 4 columns and 10 rows. We have our country, age, salary and purchased columns, then 10 rows. So for each columns, you see their data attached to it. But you will notice that in this age, there are no values for Spain under the row 7 for Spain here, as you can see when you get that in my system. And also there are no value for salary in Germany row. So we are going to be looking at that. So this is how the data is arranged. So because it's arranged that way, I want you to understand that we are going to be working with this data. Now, for us to work with this data, we have to first import this data to work with it. So let's import this data set. So to import it, we'll be using the pandas because it works with the pandas data frame. So what we'll do is that we'll create a variable called dataset. Then, since we have imported pandas as PD, what we are just calling is just PD. This is already pandas. PD dot read CSV, which is a method in Python in pandas. So what are we reading? We're going to read our data.csv. Now we have been able to import our data set. So once I run this and let's say, let me print data set. What you now see here is a replica of what we have in our data set, data.csv. So you can now see the replica. We have our country, our age, salary, and purchased. Now, what we want to do is that we want to be able to separate these values so that we can be able to work with it. So how do we do that? What we now need to do, we need to create another cell below. So we now have our X value, like our independent variable. X is what is, we are going to be representing it with X as our independent variable. So for the data set, which I've been able to import, which have been assigned to a variable called data set, they'll have dataset dot ilog. Ilog is a method in pandas that helps you to locate indexes actually in your data set, to locate those indexes. So we are going to be using that to locate these indexes because we want to get those values from the indexes. So we have data.ilog. What do we need to look for? Using a string, a list value. So from this data set, we want to be able to assign X values to the country, to the age, to the salary alone. Then these are called the independent variable, because every other thing is working on the purchased. Because someone whose age is 44, for example, someone who is 44 years old, has a salary of $72,000. So we are checking, did the person purchase something or not? That is purchase. Now, these variables, these independent variables are what the dependent variable, Y, which we'll look into very soon, is going to be using for its data. Now, what you're going to be getting is every data under country, age, and salary. Now, to do that, what we need to do is that, first of all, we'll take everything in the X row, which is represented by a column. Everything in the X row, that is everything in the row, everything in the row, we are going to take everything in the row. So having 10 rows, we are going to take everything in 10 rows. Then the column, we are only going to be taking country, age, and salary. So to do that, what we need to do is that we'll take everything minus the last value. The last value is -1, which is, it is counting from backwards. So we are removing purchased. and we are only getting country, age, and salary. So since we have been able to locate those index with the ilog function, what we now do is that we'll now get the values, because that is the values we need actually. So when we run this, if I now print X for you, let me create a new cell. If I now print X and run this, what you now see is a list of our countries, like you can see France, then the age, 44 years old for someone from France, and his salary, which is $72,000. So we have been able to get the independent variable called X. So now we'll go to get the dependent variable called Y. Y, we only want to get the column for purchased, which is the last column. So how are we going to do it? I think you should know by now. So to do that, we have to call dataset variable, which we have been able to declare initially, then .ilog, which is the index locator for our pandas data frame, since our data set has now become a data frame, pandas data frame. So .ilog, we are collecting everything in the row from the number one row to the last row, which is 10. That is what we are going to be collecting. But you will notice that in the data frame, you have 0 to 9, and you'll be wondering why I said 10 rows. In Python, list values count from 0. So when it's 0 to 9, you're just saying that there are 10 items in the list. So that's why I said 10 rows. So we are going to be taking everything in this purchase column. But since we don't want to take country, age, and salary, which we have done for the X variable, what we are going to do now is to specify very well. So what we are now going to do is taking everything in the row, then we specify that the next thing we need to take everything in the last column, which is indicated with -1 because we're counting backwards. Then since that is the case, we'll now take the values in purchased. So when I run this cell, we shift enter and then create a new cell underneath and print Y. I just want you to see what we are doing. When we now print Y, we're now saying no, yes, no, no, yes, yes, no, which corresponds to everything under purchased. So you are seeing no, yes, no, no, yes, and the rest, and the rest. Now, since we have been able to import that data from the data set, now we'll now go to the next one, which is the last for this episode, taking care of missing data. You notice, which I've already told you initially, that there are some values which are not there. For example, Germany under this index 4. The salary is none. It signifies that nothing is there. So if you go to our data.csv, you see that Germany has no data. It has no data under the salary. Spain has no age under the age column. So we are going to be handling these missing data, and there are two ways to do that. The first way is to actually delete the data since it has this missing data. But deleting the data actually doesn't make it complete, right? So what we are going to do is that we are going to take the mean value of all this whole data, compute the mean value, and input it into these spaces that are empty. So let's go into the code to know how to do that. So what we are going to do is to create a cell underneath this, taking care of data of your missing data in the data set. So since you have installed a Python library called scikit-learn, We are going to be using that for our operation here to handle missing data. So what we'll do is that we'll do type from scikit-learn dot input. That's how it's spelled. scikit-learn dot input. So now import our simple imputer, which is the library class from scikit-learn to help us to handle missing data. So for that, we now create a variable which should be the instance of this class. We have simple input like that, spelled like that, same imp, spelled like that. We have simple imputer class. So that is the object. The simple input is the object of the simple imputer class. So what are we going to do? Everywhere that is none, that is none actually, in the data set, as you can see here, none, which has no value, as I've explained earlier. We are going to be filling it up with new data, which is the mean. We'll be taking a mean from the whole data and we'll be filling it up. So what we are going to do is, first of all, what strategy are we going to use? We are going to use, since I say the mean, we are taking the mean. Now, since that is the strategy, what then should we put for each of these missing data? We are taking the mean of everything. What we need to do is that everywhere that is none, as you can see here, none, then none. Everywhere that is none, what we will do is that we have to replace this none with the mean values of all these data. So what we'll do is type missing, which is an argument in this object, missing values. So missing value should be mp.none, which is the numpy equivalent for any value that is none. That is what we are going to be doing, that is the missing value. Okay. Now, when we take this, what we'll now do is that we'll now have to fit. We've run that cell already. So since that is seen in the data set, X data set, what we'll now do is that we'll now fit this simple imputer. It should be simple input dot fit to the X variable. Okay, the X variable. So everything under X will now work on it and take care for it to take care of this missing data in data set. So run that cell. Now that is giving an error because we cannot use the mean strategy for numeric data. I was deliberate to raise this error so that you can see what we are doing. Now you see that the error says could not convert straight to float, France, for example. Now in our data set, you can see under the country column, we have France, Spain, Germany, and those countries. Now these are string values. And in working with missing data, you don't need to input string values. You might be wondering and asking why. The reason is because it only works with numeric data, and since these are strings, you shouldn't work with it. Now, for us to be able to work with numeric value, and you would notice that where this noun was, where it was noted, was only in the columns for numeric data. So from our data set X, which is the independent variable, this is the first index, the country column is the first index, 0. Then the age, the second index, 1. Then the salary is the third index, 2. So what we are going to do now is that we are going to be taking everything from the first index, removing the country column, which is noted as 0 in this numpy array. We're taking everything in the country index. We're keeping away everything in country index, then taking from the age and the salary column alone. So what we'll now do is that x, so we'll have to specify it with a square bracket, x, then we are taking everything in the row, beginning from where? From the second index. Remember I told you 0 is counting from 0, 0, 1. So 0 is the first index, 1 is the second index. You must be careful to look out for that. So we are taking everything from 1 down to 3. Now the reason why it's indicated as 3 is because it's taking it from 1, 2, then 3 is removed. Since we only need the second index and the third index, which is 0, 1, 2. So we are specifying it from 1. We are going to take everything in 1 in column 1 and everything in column 2 minus the last one, that is the third one. Sorry. So that is going to do that. So if you hit enter, you see that ran successfully. So for us to continue with that, what we also need to do is that we are going to assign it to a variable. We have x, everything in the row, then with your comma, then everything from 1 to 3, we'll assign it to a variable var, just a variable. If we hit enter, and then that is coming up with an error because we have not yet transformed the variable var. So what we are going to do is that we create a cell above first to do that. Now to do that, we need to create a variable called var. Var is a variable which we need to transform these values. So we have to do simple calling the object of the simple inputer class, simple input dot transform. What is it transforming? It's transforming everything in this x independent column. So it's transforming everything. So when we run that, see that run successfully. Then when we go to the next cell and run it, it runs successfully. So now we have been able to transform the columns in the dependent variable x into the variable var. So the variable var is containing the transformed values now from the simple inputer class, and we are assigning it back to the dependent variable. So when you now print x from here, I just want to show you, when you now print x and run it, you will notice that those places where there are no missing values, like none, you are seeing some values inside it. So actually these are correct assumptions. You are taking a mean of everything, like I told you earlier, are correct assumptions. So the one for Spain is earning 38 point. The one from Germany, sorry, is earning $63,000, $777, and the rest. Then we have the one from Spain is being assumed that his age is from 38, 39 years. So you can see that the amount of salary that the one from Germany is earning, which is 40 years, is $3,000 and $64,000. So that wraps up our tutorial for today on data preprocessing. Hello, welcome to this continuation on our data preprocessing in this machine learning series. We are going to be looking at encoding the categorical data from our data set. Then we'll be splitting this data set into training set and test sets. Then we'll now have our feature scaling. So by the end of this course, we'll be able to encode your data, split it into training set and test sets, and apply feature scaling to your data set. Now, in continuation of our data preprocessing, let's get our hands dirty. So now going into the code, we have our data preprocessing tool, as you can see on the screen, which if you noted earlier, I said we are going to look into encoding categorical data, splitting the data into training set and test set, and feature scaling. Now under encoding the categorical data, first of all, you need to ask, what are categorical data? If you take note of our data, for example, as I showed you earlier, which is this, under importing the data set, you will notice that they are under the country column. You have France, Spain, Germany, which are string values. They are not numeric data, which we can actually work with for our computation. And under purchase is either yes or a no. So come to think of it, these data really are string, and in computing mathematical values, you really don't need string values. So what we are now going to do is that we are going to transform these string values into numeric values. That is what it means by encoding categorical data. So they are based on categories. That's why I said it's encoding categorical data. So first of all, we have to encode the independent variable, which is presented as x. X are the independent variable. So create a cell underneath for us to work with this. So how to do that? We'll have to import from scikit-learn dot compose. We have to import what is called column transformer. Since we are working with columns, please just take note of the spelling, column transformer. Okay, as you can see that. Then we'll have to import our one hot encoder from the scikit-learn dot preprocessing. Then we import our one hot encoder. Okay, now what are we then going to do? For the column transformer, we'll get an instance of the class, which will assign to the variable ct. Name it column transformer. We want to transform everything in the column. So that is what it's all about. Then we'll now have to state some parameters, transformers. Sorry, the spelling is wrong. Transformers, which is equal to what? What are we transforming? First of all, the encoder. I'm going to transform it. Then we'll now also pass in the instance of the class one hot encoder. One hot encoder. Then where are we now going? Where is this operation going to happen? If you take a look at the cell, you will notice that on the x variable, France is the first index on the numpy array. So we are going to remember that I told you earlier that 0 indicates the first index. So when we now get to this part, we'll now have to take in everything in the first column, which is 0. So now we still have to take in a transformer Yes, a reminder called pass through. Reminder, pass through. Now, all these things, the transformer is actually going to be returned as a list instead of a tuple, as a list. So what we are going to do, we are going to put it in a square bracket. Yes, and that's fine. Then the next thing is that we are going to fit this column transformer, which is the instance of the class wrapped in a variable. We are going to fit it to the x values, which are the independent variables. So we'll name a variable called var and ct dot fit, or where are we going to fit it? In the x values. So transform, fit transform in the x values. So when you do that, you now have to make another variable called x and transform it to a numpy array. And transforming it to a numpy array, and we'll now run this cell. Once you run this cell, I just want you to see the outcome. Therefore, let me print x. You will notice that there are no string values in the outcome, the output. Those strings, Germany, Spain, France, have been changed to numeric data. That is what is called encoding the categorical data. So you have, for example, you have Germany, France up here. France is represented as 100, 100. Then you have Spain. Spain is represented as 001. Then you have Germany. Germany, which is the next one after Spain, is represented as 010. So we have encoded it. We can now actually work with these data. Then the next thing we also need to look into is encoding dependent variable. How do we then do that? Let's look at it. We'll have to create a cell underneath. Then since we are working with, since the dependent variable is y variable, so what we are going to do is we are going to be collecting from the y variable. So we import a class called label encoder. Now you will notice that for the y variable, they are more like a label, yes or no, being attached to all the purchases column as seen in our data set. So what we are going to do now is that we are going to import from scikit-learn dot preprocessing. We have to import label encoder. So we've run that, and that was successful. So create a new cell underneath. Let's take an instance of the class label encoder and assign it to a variable called le for label encoder. So this label encoder, we are going to fit it to the y variable. Let us name that to be, okay, let me still use y. I have le dot, we are fitting it to y variables. That is y equal to le, which is the instance of the class, dot fit transform. I'm fitting it to y. I see that I'm fitting it to y. So when we run this cell, and when we now print y, let us see how the outcome will be. So you notice that we are no longer saying yes or no. The no's have been changed to 0 and the yes have been changed to a 1 for the y variable. So that has helped us to accomplish the encoding our categorical data. Now let's go into the next part of splitting the data set into training set and test set. So create a cell underneath. So to do that,
we have to import a class called a method, a function called train test split from our scikit-learn. So you see the need why you need to install your scikit-learn as into your machine to work with it. So from scikit-learn, sorry for the misspelling it, dot model selection. Please take note of my spelling. Model selection. What we are importing is train test split. So when we run that, see that it was run successfully. So we create a cell underneath because we need to work with train test split. So for each of these values, the dependent variable and the independent variable. Independent variable is x, dependent variable y. We are going to take some values and assign it to our training set and our test set. The training set is the set of values we are going to train our model on or work on. As you go further in this machine learning series, you see us training our models. So basically, what we are going to be doing is that we've taken a data set, we want to split it into two. And it's advised that in splitting your training set and your test set, it should be 80-20 ratio percentage. Your training set should take in 80% and your training test set should take in 20%. The reason being that you need to train your data on a lot of data and then test it on the remaining. So let's work with that. So we are going to be writing some variables, x train, then x test, sorry, that is test, test. Then we're also going to be training our y and training and getting it for the training and test set. So what we are going to be calling is the train test split, an instance of the object. So to do that, we need to assign some values into this. So how we are going to do is that we are going to call the x value, the y value, then the test size, that is for the test. That is the test data, test set. That is the test size. So we are assigning it to 0.2. 0.2 being the size, which I've explained earlier to be 20%. So if we want to take the trainings, what the system is going to do is that for every test set, it will take 20% and assign 80% your training set. So that is what it's going to do. Then we'll assign another value called random state, which is 1. Everything is assigned just one value, which is 1. Then from that one, we take 0.2 and assign it to our test set, then 0.8 and assign it to our training set. So we are going to run that cell. When we now run it, I would like you to see the outcome of this cell. So what I'm going to do is now I'm going to insert a cell underneath. I've inserted a cell underneath. So I'm going to print x train so that you see the outcome. And because I'll need to also print s test, y train, y test, I'll need to duplicate this cell into 4. So we have the first part is printing the x train, the second part should print the x test, then this one should, the third part should print the y train, and then the y test. I just want you to see the outcome of it all. So when we run, you will see that this printed some values. And to show you that the length of x train has taken 80% of everything. Remember, it's 10. So 80% of 10 is just 8 values. out of it. So I would like to create a cell underneath, and what I'm going to do is that I'm going to check what is the length of X train. If I run this, you will see 8. So 8 has come out of 10, which is the 80% assigned for the training set. So because we need to train our data with 80%, we have taken 8 out of it. Then I'm also going to print our S test. You will notice that it's just only 2 out of the 10. So this is 20%. Then Y train. Y train, our Y variable took 10 out of the purchases, which is just yes or no, indicated that way, that being our categorical data, which we transformed into zeros and one, zeros being a no and yes being a one. You notice that I took 8 out of it. If you now check the length, which I should read by now, I should assume that you know how to do that. The length being of Y train, you see that it's just 8 of them. Then we'll now run for the Y test, and you can now see that it's only taking 2 out of the 10. So that just wraps it for our splitting the data set into training set and test set. Now, the last part of this tutorial, we're going to be looking at feature scaling. Before we go into feature scaling, there are some things I would like you to know. Feature scaling, you are working with your data. Have you ever thought of how are we going to, for example, if we want to plot a graph needs the same amount of value for every values. For example, it should be able to have the same amount of values in X axis and the same amount of value in the Y axis for it to be a good plot. But you will notice that on our X and Y variables, they are not the same amount of values. Just want to take note of that. So, but in our future scaling, we are going to scale everything to be on the same amount of values. That's what we are going to do. And the procedure to do that, we are going to be using a standard deviation method, wherein it should give us a range of values from -3 to +3, -2 to +3. So to do that, we need to first of all, we need to get the standardization. Then that is called standard scalar. So from scikit-learn dot preprocessing. This preprocessing function has really been so helpful. You have to import our standard scalar, since is all about taking a standard deviation. Then we'll get the instance of the object standard scalar, which we store in a variable called sc, and we're not passing anything into it. So this standard scalar, we want to fit it to our X. So we have sc.fit. We are fitting it to what? We are fitting it to our X train. Now you will take note that initially we had those categorical data which we have encoded to be 100, 010, and 001. These are called dummy variables. We don't really want to work with it. We don't really need it for our work. So what we are going to do now is that we are going to be taking the parts that we are going to be working with. We are going to be taking those parts we are going to work with. So what we are going to do is that X, we are going to be taking those parts. We take everything in the row, then from 1 to 3, which I've explained earlier. For you to understand it, you need to check out our previous tutorial on this. Then it is transforming it, fit transform, What is it transforming? Our x, which is taken from 1 to 3. That is for our training set. That is for our training set. Now, if we run this, that was successful. Yet, I still want to print out x train for you to see what is the output. X train, you will discover that these values are between, for this point you picked, which is 1 to 3, which is this and this. Okay, let me print it out very well so you can see it. Every value again 1 to 3. So you will notice that from every values 1 to 3, that it is between -3 and 3. So you have minus 0.577 and you have 1.29. You know, these are the range of values. So we are still going to do that for our x test, which is the independent variable. For our s test, what we now have to do for s test, we still collect everything 1:3. Then we are going to do sc dot fit. What are you fitting? Our s test. Sorry about that. Our s test 1:3 again. So what we are basically taking, we are removing other external things, the categorical data, shifting it aside, and we are now taking the values that falls from index 1 and 2 aside 3. So I'm going to fit, not fit, sorry, I'm going to transform this. So when we run that runs successfully, then I would like to print x test so that you will see what is the outcome. So s test 1:3. Let's print that. So you can now see that we have been able to standardize. This is feature scaling. We have been able to standardize our work. So we have been able to feed those things using our standard scalar class, thanks to scikit-learn. It has been so helpful for us in this tutorial. So every part from those 3 columns, which represents the age and the salary, those 3 columns, we have been able to specify them, to set them into a standard scale from -3 to +3 for both of them. So that wraps it up for our tutorial today. Thanks for being there. Hello, welcome back to the 4th episode on our machine learning series. We are going to be looking at regression. You might wonder, what is regression? Regression are used to predict real values like your salary. This can be linear or non-linear values. Now, these regression values, when they predict things based on time, for example, they are present values. When they predict things like time and forecast things like time, they are also futuristic values. For example, you want to be able to predict the outcome of something in the next 10 years. You need to predict that based on time, and regression will help you do that. Now, it can be either a linear regression or a non-linear. This can vary from our normal linear regression to our support vector regression and the random forest regression. In this tutorial today, we are going to be looking at simple linear regression. Simple linear regression we are going to be looking at is a build-up of our data preprocessing course, which you will do well to look into. We are going to be studying on importing the data set, splitting the data into training set and test set. Then we'll apply our linear regression to this training set and test set, which we have been able to split. So at the end of this course, you are going to understand and know how to work with linear regression. Now, for this course on simple linear regression, let's get our hands dirty. I know you're excited about it. So, first of all, we are going to be importing the library. And the libraries we are going to be using are NumPy, pandas, and matplotlib. Then every other one should follow. So, on this new cell, what we will do is we'll import NumPy as MP. Then we'll import our pandas as PD. Then we'll import from matplotlib, import pyplot as PLT. Now we are going to run that cell, which when you see it, you notice that that is successful. Then we import our data set. For us to import our data set, there's something I must let you understand. First, let's study about data set. It's called data set salary. This is just having 2 columns and 30 rows. The 2 columns have the years of experience and your salary. So for every year of experience, salary increases based on your year of experiences. So from the data set, we are seeing that we are only going to be working with 2 columns. Now, let's go back to our code and import this data set called salary data. So we are going to be creating a variable called data set. Then we'll call the pandas dot read CSV, which should be a method in it. So what are we reading? Salary data dot CSV. So I would like to print our data so that you see what is in our data set. So let me print our data set. So you can see that we have successfully imported everything in our .csv file, salary data.csv file. Have your years of experience and have your salary. So now we are going to work with this like we've done earlier. By now it shouldn't be difficult for you anyway. So we are going to be taking the x and y variables, the x being an independent variable and the y being a dependent variable. So create a cell underneath. I'm going to be taking everything is similar to the first one, so you can easily copy and paste. But for us to understand it better and to get our hands dirty more about the code, I would like to write it out. We have data sets which had become a pandas data frame .ilog. ilog, taking everything in the row and everything in the column minus the last column. Then we take the values in it. The same if we run this cell, run successfully, and I would like to show you our x. What is in our x? So you can see that everything in our years of experience is now assigned to our x variable. So also for y, you now have to do y equal to the pandas data frame .ilog. We are taking everything from the rows and the last column, then values. So when you print y, let me create a new cell. When you print y, see that all the salaries are taken up, which is a numpy array. So we have been able to import our data set and utilize every data in the data set. So for the next tutorial, we are going to be splitting this data into training set and test set, which by now, if you follow through from the previous tutorial, you shall have been able to understand it better and seeing how it was done. So what we are going to be doing is that we're going to be taking it from scikit-learn dot model selection. Import, what are we importing? We are importing our train test split, which if you run, it runs successfully. So create a cell underneath and you assign the training set and the test set. Remember 80-20 ratio. So S train, S test, Y train, Y test. We are assigning it to the train test split, the instance of the train test split method. So what are we taking? We are taking the test size, which should be equal to 0.2, as I've told you, and the random state, which is 1. Then, since we'll be taking it, we'll be applying it to our x and y variables. So what I'm going to put here is x and y variables. Then we'll run that cell and then that runs successfully. So we create another cell underneath. Then what we are going to do is that we are going to print for you to see it, our x train. We've taken 80% of 30. If perhaps you want to check the length of this train, x train, let us take the length x train. You see, it's 24. So if you do 80% of 30, it's going to give you 24. Just a little mathematics there. So I'm also going to be printing for you to see it. It might not really be necessary, but just for us to understand what we are doing, we have to print everything. We'll be printing our x test, which will duplicate for the rest. So here we'll be printing our y train, and the next cell we'll be printing our y test. So if you run this, you see that just took 6 of everything in the y, in the x independent variable, then 24 in the y train, then 6 in the y test. So that is just it for splitting our data into training set and test set. Now let's go to this part of training the linear regression method on the training set and the test set. So I'm going to put in a new cell from scikit-learn dot linear regression import linear. Just take note of the spelling, please. Regression. So if we import that, actually the spelling is linear model. So if you go perhaps to scikit-learn, their documentation about linear regression, you see it's been gotten from the linear model from scikit-learn. So when we run that, it was successful. So what we are going to do, we create a cell underneath. Then we are going to be working with the instance of the class linear regression. So let's call that, if you are working with simple linear regression, same lane regress. Same lane regress, which should be an instance of the class linear regression. So we are not passing any parameter into it. So we've run that, and that was successful. Then we'll create a new cell underneath, and we'll have to train this data, this training set and test set on the simple linear regression. Now, what we need to do is that we need to do, let's pass this to a variable, let's call it var, same lane regress dot fit your x string together with your y string. We will not need any variable for that. So, but let's run this, and you notice that ran successfully. It told us that it's a linear regression. So that wraps it up for our first tutorial on simple linear regression. Still on simple linear regression. This part, we are going to be looking into visualizing this data after we have been able to train it based on our training set and test set. This training set and this test set, which I've been able to speak earlier in our first video on simple linear regression, we are going to test it on the test set to see the results. When we do that, we'll visualize it using matplotlib. Matplotlib is a package from Python for data visualization. I'm going to be basically visualizing this data. So at the end of this course, you will be able to know how to predict your trained set with the simple linear regression on your test set, then visualize this data to see how it plays out. Now, for the second part of this tutorial on simple linear regression, let's practice. So we are going to be predicting the test set results before we visualize on the training set results and we visualize the test set result. So first of all, what we are going to be doing, we're going to be creating a variable called ypred because we are going to be predicting on the test set. Remember I told you that the y, which is the independent variable, is taking up the test set. We have the test set for the x variables, and the test set for y variable. But now we are going to be predicting it on the test set of the x variable. So remember, if you can recall on our last tutorial, which you need to watch before this, we named the regressor class, simple linear regressor class, as sim lane regress. So I'm going to be copying that. Then I have to paste it here. Sim lane regress dot predict. What are we predicting? Our S test. As you can see, then run that. That ran successfully. Also, we need to be predicting for the y variable so that when we are plotting everything, you see how the line graph is going to go. So to do that, what we need to do, create a variable called xspread, and we'll call the instance of this linear regression class sim lane regress dot predict. What are we predicting? We are predicting everything in the train X train. So when we run that, that runs successfully. Now, that was for the first part of predicting test set results. So let's look at visualizing the training set. And for me, I'm excited because I'm going to see how these data which I've worked on, how it is going to be played out. This is good for every data analyst or any data scientist to learn. Now, under visualizing the train set result, I'm going to create a new cell underneath, and the new cell I'm going to be visualizing. So, since we have, if you can recall, we imported matplotlib as PLT, as you can see from the video, as PLT. So, we'll now have to use that PLT. So everything in matplotlib has been put into the keyword PLT. So PLT dot scatter. We're taking a scatter plot for the Y spread, then the X string, and what color should it be? The color should be red. Sorry for that. It should be X string and your Y train. So also plot a plot. Initially we had to do a scatter plot for the first one, and for each point, a scatter plot in matplotlib just put a dot for each point in a graph. But in a dot plot, it's going to draw a straight line across the graph. That's what it's going to do. So to do that, we have to work on the X string and the X spread, and we'll give it a color of blue. So to plot it, you have to do X string X spread, which is the variable we had initially, and the color will be blue. Then for that, we'll now have to do every other styling. We'll give the title for the plot. Let's call it salary versus experience. Salary versus experience. Then for the X label should be the experience. Yes. Then the Y label should be the person's salary in dollars. You should understand that in dollars. So since you are working with this on the training set, I'll have to do salary versus experience on training set, because we also work with it on the test set too. So I just want you to know that. So the last thing for writing on this code, I'd like to show what the data is all about. So hold your breath a little, because it should be fantastic. So if I hit shift plus enter, we are seeing a plot, salary versus experience. You will note that the salary is on the x-axis, the salary is on the y-axis, sorry for that. Then the experience, which is in years, is on the x-axis. And this red spot shows a prediction on the x train and y train. The y, which are the matrix of features of the dependent variables, and x train, which are the matrix of features of the independent variable. Yeah, noted here with the red color dots. Then taking the X train with the predicted value, which is predicted with the simple linear regression, which is an instance of the simple linear regression class called the same plane regression. So it's just a plot, which is the view plot around it. So that is for the training set. For the test set, I'll just have to copy this code and create a new cell underneath, visualizing the test set result, paste it. Then we'll have to edit some things like training test set result. Then since we are training it on it should be the X train and the Y spread. And this should be edited to be X test, Y test. So this should be X test, Y test, then it should be X train and X spread. So if we run that, that gives us now another graph, which is for the test set. The red dotted point shows the scatter plots for the S test and the Y test. Then the blue line shows the plot on the X train and the predicted value for the X independent variable. So that is what it's all about. We have been able to visualize these data. Look at how it looks. It looks really wonderful for you to be able to visualize this data to know, okay, say for instance, someone comes with an experience and of having 5 years experience on his work. How are you going to train? How are you going to pay the person? What are the salary ranges you're going to use to to pay the person? So from what we've done, I've been able to predict, giving a prediction. Okay, someone you working having a 5 years experience, what are the likely amount? So if you check around there, it should be going to this. It should be around, let me say, $70,000. $70,000. So with that, you can be able to tell your establishment or your firm or your organization that this should be their amount to pay someone who has 5 years experience. So that wraps it up for our tutorial on simple linear regression. Welcome to this new episode on our machine learning series. Today, we are going to look into multiple linear regression. And you might be wondering what is multiple linear regression. Just a build up of our last episode on linear regression. Multiple linear regression is when you have one dependent variable with several independent variables. Like, take for instance, you want to be able to check the output in a company, and they have several cells of the company, like the R&D, research and development, the administration, the marketing sections of that company. I want to check the output each day for each section of the company. Multiple linear regression can help you with that. So the company is the dependent variable. The independent variables are those departments. So when they work together, all these things, all these departments, which are the variables, makes up, that are so many actually, makes up what we call multiple linear regression with respect to the company as a whole. So today on our list, we are going to be looking at importing our libraries, importing our data sets. Then we'll be encoding the categorical data. Perhaps if you want to name your company, based on their variables, the independent variables, like the accounting department of that company, like the administrative part of that company, and the rest, then this can be under the categorical data. where you have to encode the categorical data. Then you have to split the data into training set and test set. Train the multiple linear regression on the training set after you splitted it, because that is the fun part of machine learning. Then you predict the test set results and evaluate the score performance. So by the end of this course, you'll be able to learn how to use multiple linear regression to check several variables. Let's jump into the code. So we are going to be importing the libraries. And from our last tutorial, we saw that necessary libraries are NumPy, which is Python, numeric Python. So we import NumPy as MP. Then we import pandas as PD. Then we import matplotlib for our visualization .pyplot as PLT. So when we run that cell, then we have to import our data set. But before we import our data set, I'd like you to just look at the data set startups. So we have, for example, in a company and in a state, we have New York, we have California, Florida, and the rest. Then we have the marketing expenditures for each of these company. We have the R&D spend, administration, and the marketing department spend. And we can see from R&D, administration, marketing spend are all numeric values. The states are dummy variables, which are actually not numbers. They are string characters. Then the profit. So what we are basically going to do is to take from the first column to the second to the last column for our X variable. Then the Y variable, which is our dependent variable, is the profit. So that we use these things to check what are the profit outputs for each of the department. So now let's go into our code. We have to import our data set. Then let's call that data set. pd.read is a CSV file. CSV name startups .csv. Okay. So take our X variable, we take the first 4 columns of ilog. Remember our ilog value. Then it's taking everything except the last variable and the values in it. Then our Y is taking everything in the data set. I mean, in the X, in the row, everything in the row. Then if you take everything in the last column of values. So run that cell and we are up to go. Then encoding our categorical data, we have to, first of all, import some libraries from scikit-learn. We have scikit-learn dot compose. We have to import our column transformer. Then from scikit-learn dot preprocessor, we have to import our 1-hot encoder. So we take an instance of the column transformer and we call that instance of the column transformer class to be CT. That is a variable CT. So what we are basically going to do is that we are going to encode those states like New York, Florida, and California. We're going to encode them into numeric values like we've done last time. So we will not have to stay so much on this. We have to call our transformers before encoder. This should collect a list of values on hot encoder class. Then where are we going to apply it? I'm going to apply it in column 3. There we have our pass through. Yes. So now what we have here is to transform everything in that column to a numeric value, 1 and zeros. So what we are going to do next is to fit that to the X column. We'll use CT dot fit transform. Then MP dot array, converting it to a numpy array, the variable. That was successful. So let us split the data set into the training set and test set. So from scikit-learn dot model selection, import train test split. So that is to import our training and test split, to split it into training set and test set. So we will now have to execute that, and that works very fine. So the next thing is to now split it into training set and test set. So we have x train variable for x train, x test, y train, y test in train test split class. So we are taking a random states of 1. We're also taking a test size of 0.2 and passing it to the x and y part of our variable. Then after that, sorry, we are not iterating through it. After that, we executed that successfully. So now let's train the multiple linear regression on the training set. So we have that from scikit-learn dot regressor. We're going to import linear regression. not dot regressor, sorry, dot linear model. So let's call this linear mod regressor, and we are passing it as an instance of the class. So we are going to fit that for our X and Y train. Not regression. So that runs successfully. So we'll predict what we've trained already on our test set. So let's go with that. So we have y thread. Let's take that as a variable. Let's call our instance of the multiple linear regressor class. Anyway, the linear regressor class for this time around, they're using it for multiple tasks. We are predicting. What are we predicting? We want to predict it on our X test. So that line does that. Then set mp dot set print options. What are we setting? We are taking a precision of 2. So it will be good if you can be able to go online to scikit-learn website so that you can be able to see how to use these models, these classes to work to build your model. So we have, let us concatenate. What are we concatenating? What are we bringing together? We are bringing together our Y thread and our Y test. That is the predicted one on our X test. So we are taking Y thread dot, let us reshape it so that both of them will have the same shape. Take the length, Y thread, we are reshaping it to 1. Then, since it's a concatenation, also concatenating it with the Y test. So we have comma Y test dot reshape. What are we reshaping? The length of Y test into 1. Then we are now reshaping everything into 1. So when we run this code, it says incomplete input. Let's do that line. Let's put it in a variable first. Let me call that var. So let's print that. Let's print var. So now what I'm going to do is that I have to turn that off. Then ypred dot reshape. We are reshaping it, and so that it will be of the same dimension, as your Y test. So if you run that runs successfully. So let's evaluate the model performance. How was that? What is the accuracy of that model? And checking the model performance. So what we have to do is that we have to import on scikit-learn dot arrow2 dot metrics, import arrow2 model. You have to run that is arrow2 score, not arrow2 model. So with arrow2 score, we check the model performance. What are we checking? We are checking it with our y test and our y pred. So it gave us a 96% performance of our model. So we have been able to train our model with several variables in the linear multiple regression. So we have several variables which are independent variables. We're able to test it, and we saw that it gave us a prediction of 96%. Hello and welcome to this 7th episode on our machine learning series. Today we are going to look at polynomial linear regression. And in your normal mathematics, if you have done things like polynomials, this is just an example, and it's used to predict, pandemic outspread, and it's used to predict salaries. For example, you have a company and someone just walks up to the company and wants to apply maybe as a sales manager, and you want to train a model to be able to predict, for example, the person's salary based on the person's work experience, since he said he's a sales manager. So what we are going to work in, we are going to work with we are going to train a model to predict what can actually be the person's salary. Since that is what we are going to work with. So let's jump into the code. So let's have a look on our data set first of all, before we go into the code very well. So we have positions and their salaries. We have business analyst, as you can see in the table. So we will not be working with all those dummy variables as you can see in the first column. So we have to ignore them. We'll be working with the levels and the salaries. So let's go back to our regressor. I have to import the necessary libraries. We import our numeric Python as MP, import pandas as PLT, and import matplotlib. This time around, let's use another conventional form. Matplotlib, import pyplot as PLT. So we'll run that, then we'll now have to import our data set. pd.read CSV, position salaries.csv, as pd here. That's where the error is coming from. Position salaries, then we'll take our x independent variable as dataset dot with the ilog function, which is a pandas function. We take everything in the row. Since we don't need the first column, we'll just take it from first to the last column, and the values in the y dataset dot ilog everything in the row and in the last in the values. So that was done successfully. So we are going to train the whole data set on the linear regressor. So to do that, first of all, what we have to do is we have to import our linear regressor class dot linear model import linear regression. Okay, let me call that linreg, which is the instance of the class the linear regression. Yes. Then the next thing, we are going to fit it to our x and y variables. Okay, that runs successfully. So let's train the polynomial linear regression model on the whole data set. So from scikit-learn dot preprocessor import polynomial features. Okay, so let's name that variable as home reg. So which is an instance of the polynomial features class. So we'll pass the degree. Note, just like you have in your polynomial series mathematics, such that you have a degree in your polynomials. You know, for you to do very well in this machine learning series, you have to be good at least in your mathematics. So having a degree, let us take 2 for example, since polynomials are seen to start from degree of 2 and above. So let's work with that. So we have to fit it to our whole data set. So we have reg dot fit and we are fitting it to x, and we are fixing that for x transform. Now put that in a variable called x poly. Next thing, what we then have to do is we now have to create another variable. This time a linear regressor instance. And you have to fit both to a y variable, since what we are going to basically do here is that we have a degree of a polynomial variable. So we want to fit everything within an x. We want to make it to just be just one x axis. So even if it's 3 to 5 degrees and above, you want to just take all of them, you want to put all of them in an x variable, an x axis, just in one single x axis. Then you now put everything together, you now fit it to your x and y axis. That is what we are doing here basically. So you have your lane reg 2, which is the second linear regressor. We'll now fit it. What we are fitting x poly and then your y variable. So run that. Now run successfully. So let's visualize the result for the linear regressor. So to visualize the results, we'll call in our visualization, our library for visualization, which is matplotlib, but we imported it as PLT. PLT, first of all, take scatter plot. Are we plotting the scatter plot? We are plotting X and Y, position and their salaries. If you remember, those positions were graded based on their levels, as you can see on the dataset, on their levels. So I'm going to be plotting this point from 1 to 10, their salaries. Then X and Y, we need the color of red. So now PLT dot plot, what are we plotting? X. Then remember our lane reg, which is for the first one. Then we are plotting X variable, the X variables, which are the levels on the X axis. Then the lane reg, which are the variables on the Y axis, which we have been able to train for our linear regression method, so that you can just see the way the curve went, the line went. So lane reg dot predict. What are we predicting? Our X. Then we'll give it a color of blue. So let's just name that. We'll name our X label to be our positions. Then our Y label to be our salaries. Then we don't have anything much to do. So we have to show the output of it. Yes, we also like to give it a title. Title. We are going to call it salary prediction. Because like I told you can use it to predict salaries on a pandemic outbreak and the rest. So if you run that, if you look at our plots, this red dot shows the points on the axis. And this line I went through, which is the blue line, shows the prediction based on our trained model. So look at how that is. It's looking fancy. Now that is where the polynomial linear regressor comes in, which we'll talk about in the next series. So stay tuned.
Welcome to this new lesson and machine learning series. In this introduction, we are going to be working on support vectors regression on our regression series. So this is just the data set. First of all, as a data analyst or a machine learning engineer, you need to understand your data set. So in this data set, we have a position in a company, the level and the salary for each level in each position. So looking at it, you can see this is a continuous value. So regression predicts continuous values. So we are going to be basically predicting the salaries for each level. So first of all, we are going to import our data, our libraries, necessary libraries. So first import numpy as np, and import our pandas library as pd. Then we import matplotlib, which is used for visualization, .pyplot as plt. Then from scikit-learn, we import our standard scaler for scaling our data. Yes. So basically for these tutorials, this is just what we need for it. So run that cell, then we'll now have to import our data set, that is this position salaries which was shown earlier. So we'll call that data set as our variable. Then from the pandas library, we'll read the CSV file. This CSV by default is comma is it uses a delimiter of a comma. Then we pass in a file. You should know that it should be either in the same directory, your working directory, or just make sure you can just locate the file and pass the file path to it. Then we'll have to declare our X variable. X variable will call the data sets, and from position salaries, the X variable is the level, and the Y, which is our dependent variable, and X independent variable, because we are predicting the Y as the salary based on the levels. So we will take in the level. Please make sure this is correctly spelled, and whatsoever capital lowercase letters are there, you should just take note of that. That is how it is written in levels, values. In data sets, we have salary. Okay, that's spelled salary. And the values attached to it. That is, you are just basically taking the values. So I'll run this cell, and that was run successfully. So if we are to create another cell to just visualize what our X is, you see that it took all the levels. Then if you are also to check what Y is, you see that it took all the salaries. So now we are going to go into our future scaling, and I advise that you normally do your future scaling after a split, but because we are basically working on a little data that don't need splitting, I will just leave splitting by the side first. Then you call your standard scalar class, standard scalar object. So now, what are we basically going to do here? We are basically going to convert this to a standard. Yes, but this standard scalar object actually needs a two-dimensional array in the class. So what I'm going to do first of all is to convert our X and Y components into a 2D arrays. So X, MP dot reshape, let me reshape it. And whatever is the length of X, shape it. Then I'm going to reshape that. So also I'm also going to reshape Y too, so that all will be in a two-dimensional array. So if I print X and Y, you notice now that it has two braces, two square brackets. That is for Y, that is for X. And if I print Y, also you notice two square brackets. So now let us go over as standard scalar. Now we'll have to scale it for X and Y. So I'm going to call it X standard. Yes, then passing the object Then I'm going to fit it into the X, whatever is in the X, dot fit X. That's fit transform. So I'm also going to do that for Y. So I'm basically going to copy this and in a new cell, paste it, then do that for the Y variable. And run that cell. Now, the next thing we are going to do, we are going to be training the support vector regression model on the whole data set. So I'm going to be calling the support vector class. So we've not yet imported that. So I'm going to be importing from scikit-learn dot sv dot svm. I'm going to be importing svr. So for the objects, let me call it svr. Import svr. That is the object class. So I'm going to give it a kernel of ROBF, which is radio based function. Then I'm also going to fit it into our X and Y variable class. So I'm going to do svr.fit, that is to predict it X and Y. So I'm going to run that. It's meant to be spelled kernel, not E now. It's the correct spelling. So I've done the fitting here. So that is it for it. Then perhaps let's predict a new result for a model. So what value are we going to predict based on we have? So I'm going to predict first that, let me say what level now. I'm going to predict the region manager salary, who is a level 6 in the company. So first of all, I have to transform transforming it. Dot transform. I'm going to transform the SVR class. Then basically that is for level 6. So I'm basically going to convert that, I'm going to transform it. So the next thing for us to do now is I'm going to use the regressor class which I just created here, which is SVR, now to predict the value. So I'm going to call that svr.predict. What am I predicting? 1. That's what I'm predicting. So now that is the point. Then I have to reshape it first to two-dimensional array, because if you run this cell and you print X, you notice it's a one-dimensional array here, having only one square bracket. So I'm going to reshape it. Dot reshape. So whatever be the length, I'm going to reshape it into a one-dimensional array. So if I run this, I print, you see it's now a two-dimensional array. So what we'll need to do in the next result is to predict our new results, that is level 6 results. So basically, I'll have to do that for y too. So let me copy this and paste it in a new cell. So this is for y. I'm going to change everything. And I'm going to have to change the value here too. So x svr, whatever be the value, I'm going to transform it. It's meant to be an inverse transform. So if I print this, you see, it's predicted that the value is $140,000, which here is 150. So it's so much so close, $145,000. So it's so much so close. So now that brings us to the end of this first part of the program. So now, from our last tutorial, we are able to predict the salary of the regional manager of a company. So which has a level 6, which based on our prediction, we're able to get that the price should be $145,000. Now, what we are going to be doing now is to visualize the SVR results. So I'm going to create a new cell under this, and since we've imported matplotlib, which helps us for visualization, I don't need to do that again. So I'm going to go straight up. Now I'm going to get the inverse function for x and y. So I'm going to do it ysc dot inverse transform. It's transforming whatsoever be the value of y as for y inverse. Then I'm also going to be getting the inverse transform of our s variable, x variable. So now I'm going to be executing that cell, and then the inverse, I'm going to be predicting what the value may be, first of all. So I'll call this x inverse spread. Then I'm going to get the inverse transform. Then I'm also going to be getting the regressor class, which we passing into the SVR variable. And I'm going to be predicting the x values. Now, because I'm going to be predicting it, the inverse transform only takes a 2-dimensional array. So I'm also going to be reshaping this with 2-dimensional array. Yes, so I'm going to be executing that cell, and then if we print that x inverse spread, you see that is the inverse and it's a 2-dimensional array. So now the next thing for us to do is to do the actual visualization. Yes, the actual visualization. So the matplotlib scatter plots to point each values in the data set which you've gotten, then get the x inverse, then the y inverse too, as for each value. Now give it a color of, let's say, color red. Yeah, color red, and BLT dots. Then we'll have to plot this for line plots. Then what we are plotting across the dots is the x inverse, then the s inverse what we predicted, right? Then we give it a color of, let me say, green. Yeah, green will go very well. Then I'll give it a title if need be. So let's call that salary predictor. Okay, based on positions. And this is for SPR. Okay. Then we'll also give the Y label and the X label. X label is the position, based on what we have in the data set, position, and the Y label should be the salary. So the last thing we need to do here, we need to show the plot. plt.show. When we run that, we see this is the visualization of what we've just basically done. So every value, every salary level, this is the visualization, and you will notice that the line does not really correspond to the dots. So, but you will notice at position 6 is the position. At position 6, we have that somehow it's overlapped, the line overlapped on it. So this shows that somehow we are able to predict that the salary is on this or this position. So I'm also going to predict for higher resolution, since that this visualization is not really very, very wonderful. So I'm going to be visualizing it for a higher resolution. So since we have been able to import the matplotlib class, so we are going to basically do is to give it a range of values which we'll be working with. So let us say x, let's call it variable called screed. We're going to be giving it a range, np.arange, and we'll take the minimum value of the x inverse, yeah, and then the maximum value of the x inverse, that is the range we want to work with, and give it a step size of 0.1. Okay. Then the next thing we need to do is we need to reshape this, yes, to a two-dimensional array. Screed equal to screed. We want to reshape. We are reshaping the length. Screed. Whatever be the length, we'll reshape it. Yeah. So that is what we need to do for higher resolutions. Then the next thing we need to do also is that we need to be able to scale this. Let's call it a scale. What we are going to do is that for the x standard scalar, or the x variable, we need to transform what we have done, which is the screed. We need to transform it. Then using the SVR, we need to predict our values. So x scaled, which is the variable, we need to predict. So we'll call our object SVR, and we'll have to scale do dot predict. Since we have scaled it, what are we predicting? We are predicting x scaled. Okay. So one more thing is that we need to reshape our scale. our predicted scale, we'll have to reshape it. Dot reshape. It's being reshaped, whatever length it may be. So scaled spread. Need to reshape it. Then also we'll have to do that for the y variable too. So to do that, I have to execute the cell. Okay, we encountered an error. So it should be x, sorry, that is x underscore grade. Yeah. Sorry, that was a mistake. X underscore grade. So we executed that cell, meaning that it ran successfully. So for the y, I'll call that ysc y. That is a variable name. You need to have a good variable name and definition for your variables. So we are going to get the ysc as and do an inverse transform. And then this inverse transform will take the x scaled as a parameter. So we execute that cell. So let us basically go and copy this, whatever we've done here. I don't need to start, writing the whole code. All I just need to do is just to write everything together. So we'll call this ysc, then this one the x cubed, right? Yeah. So this is for higher resolution. A solution. I'm going to run that. So is really not looking wonderful because actually I'm missing something. Yes, it's going to be s cubed. So actually what is meant to be is the s cubed grid which we took. So let's see this. And if we run that, is looking much more. So it's meant to be the FTL grid because we gave it a range of 0.1. So that's what we are going to be predicting as the range so that it makes it. Now, if you look, this curve is much more smoother. Why the first one wasn't very smooth. So that will help you to get a more higher resolution. So just know how to tweak it in between, and so that the curve can be much more smoother compared to the previous one, as you have seen. Welcome to this new tutorial on our machine learning series. Now, this on decision tree regression is also part of our regression series. The last time we did support vectors regression. So, I'm showing you, we are still going to use the same data set, which is the position salary level, to predict salary of every level. So basically, we are going to be doing what we've done before. So let's import our data set. So we import numpy as np, or import our pandas as pd, or import matplotlib .pyplot for our visualization. Import it as plt. Then we'll have to import our decision tree dataset. So from scikit-learn dot tree, import our decision tree regressor. Okay, decision tree regressor. So we execute that cell. and that cell was executed, then this is meant to be import the data set. So we are going to import the data set for our work, which is identical to what we've done before. So data set equals bd.read CSV. Okay. So the name of the file is position salaries or CSV. And we get our X, which is our independent variable. We are getting the level and the values. Then for Y2, we'll get the salary. So we execute that. Now we have imported the data set. So we'll have to train our decision regression model on the whole data set. So since we've imported that, we'll just call the function, the object. So I'll name that dt as the regressor class. So decision tree regressor. We just call the object, give it a random state of 0, like initially, like nothing is going to run in it. So we'll now have to predict it dot fit, to train whatsoever is in our X and Y. Then you should take note that these X and Y values, if I'm to print it out, let me print it out, is in a 1D array. You see just one bracket. Then if I print out Y, it's just in a 1D, so you just have one square bracket. So if I run this cell, it's going to run into an error because it needs a two-dimensional array. So what I'm going to do here basically is to transform X and Y into a 2D array. So I'm going to do x.reshape, whatsoever be the length of X. Then also do that for Y too. Whatsoever be the length of Y. I'm going to execute that cell. So if I run this cell, we have basically trained the whole data set on this model. So I'm going to now be predicting a new result here on the data set. So let me predict this value of the regional manager, which is 6. So I'm going to do that right away. I'm going to call the decision tree object. So I'm going to do dt, dt dot predict. What am I predicting? I'm going to pass the value of 6 inside it. Let's see what. So we discovered that when we passed in the value, it gave us $15,000, which is the same with the regional manager. So let's try another level. Let me say level 9. So if I pass in 9, it gave us $500,000, which is the same. So this model basically does it better and better. So in the next tutorial, we're going to be visualizing it. This is the second part of our decision tree regressor lesson. So if at this point you've not yet subscribed to Smiles Tech for more tutorials, I think you are wrong. Actually, you are wrong. So I want you to subscribe, hit the subscribe button and share with your friends so that we can produce more videos like this for you. So we are going to be visualizing the decision tree regression results. Last time you were able to get a prediction, which is almost, in fact, the same actually. So First of all, we need to get our X grade, since you are doing it on a high resolution, that's spelled resolution. So since you are doing it on a high resolution, let's get whatsoever be the value, np dot a range. We get a range of values within the minimum of our X value and the maximum of our X value from level 1 to 10. So we will take a step size of 0.1. Now, we also need to be shaping that to a two-dimensional array. Yes, dot reshape. Whatsoever be the length, X grid. We'll have to take that. So when we execute that cell, now since we have imported the matplotlib library, all we need to be doing now is that we need to plot the visualization. So I'll call plt.scatter, get the scatter plot visualization, X and Y variable, giving it a color. Let's change the color today. So I'll just try blue. Every scatter plot. Then plt.plot. Let's get a line plot. What are we plotting against? We are getting S grid. Then the regression class, we are getting a prediction of X grid. Every value in X grid. Then we'll give it a color. Let's say red this time around. Then give it a title. Position versus salary prediction. Then plt.x label. What should be in the X, which is the position, as the level. And we put that in the brackets, level. Then we get the salary for the X level. Okay. Then we'll show our plots. So I'm going to execute that. So if you look at this, wow, it's very interesting. So did you see the way the plot is? It's going like in a zigzag form. A zigzag form. So the first point is a point from the minimum value, a range. Let me say the range. Okay, let me use this point 8. Minimum value from between 7 and maximum to 8 point something. Let me say 8.3. So that is what it basically aligns. And I also want to advise that decision tree regressor is not the best, to predict continuous value on a single feature. As you have seen, just the single feature salary, which is all you're predicting. So it does better on multiple features. So that is just it. Since you have seen a visualization for the decision tree regressor. So that is just it for today's tutorial. I hope you enjoy. Please learn to subscribe and to share with your friends. Thank you so much. We'll meet in the next tutorial. In this new tutorial in our machine learning series, we're going to be looking at random forest regression. We're going to be predicting our position salaries, which is a normal data set, the random forest regression. So in importing the library, we import our normal library. So import numpy as np, or import pandas as pd, we import matplotlib for our visualization, plot as plt, Then from scikit-learn, oh my God, scikit-learn is a very good extensive library for machine learning. Assemble, we have to import this random forest. Okay, regressor. Yeah, so I'm going to execute that, and now it executed successfully. So I'm going to be importing our data set, which is the position salary. So I will use pandas rate CSV. Salaries.csv. Then get the x, which is the independent variable, which is the level we're predicting asset level, and get the values. And for y, data set, and get the salary, and whatever values it is, execute that. Sorry, that is meant to be a bracket, not a square bracket. I just forgot. Sorry, I just forgot that. So we'll have now, since if we print the values of x and y, they are both in a one-dimensional array. Yeah. So to change it in a two-dimensional array, all we need to do is to reshape. So let's reshape x and y. But because our regressor class will only take a two-dimensional array, and whatsoever be the length, we'll reshape that. And for y dot reshape length of y. Yeah, so now let's train the model on the whole data set and see how it performs. So since you've imported that, I'll just call rf r, meaning random forest regressor, and to get the random forest object. So we'll just pass in a random state of 0 first of all. Then we'll give it an estimation, an estimator. Let's say an estimator of 1,000. Yeah. So we'll train it on our whole data set. So R fit x and y. We'll train it. Okay, it's S estimators. Yeah. So basically, we have been able to train that on the whole data set. So we'll predict a new result. And let's see how this one is being able to perform when we are trying to predict a new result. So rfr dot predict. What is it predicting? Let's pass in a level of regional manager. Okay, this time around the manager, which is level 4. Let's see what the salary may be. So it predicted that the salary is $76,000, $77,000. So let's check manager $8,000. So it's not really, but slightly, it's almost close to the value. So I'll advise that in training, in getting training regressor value, knowing the one that's performed best, you try all the available options, which we've seen from the tutorials. And if you go back to polynomial regression, random forest last year, having now, we have decision tree, SVR, check all of them and know which performs better. Then you can use it for predictions. Now, this is the second part of our random forest regression. Like I told you before in the earlier videos, regression basically is to predict continuous values. Maybe the prices of houses, pandemic outbreak. At this point, we are predicting salaries based on levels, so it's a continuous value. So based on our prediction in our last video, we're able to predict that a level 4 um, uh, employee is going to be having a price of $77,000, which is not very well adapted to our data set, but at least it gave us a value. So let's visualize what it's all about, giving it a high resolution. Sorry. So we'll be calling our S grid, and then we'll be giving it a range, np.arange. And the range is going to be the minimum value of whatever be the value of x, the maximum value of whatever be the value of x, having a step size of 0.1. Okay, then we'll have to resize the grids to be a 2D array. So reshape. I have to reshape it to be 2D array. Or whatever be the length of the x grid. Yeah. So we execute that, and that's executed well. So we'll be basically doing writing the code for the visualization. So first of all, the last time we used different colors, but let's just try to know what color we can use for this particular visualization. So we'll call PLT, which we've imported from our matplotlib class. So all the scatter plot of our X and Y. And let's give it a color of, let me say something you can easily see, red this time around. Now, plot our X grid against our predicted value, yes, of X grid, whatever be in the value of X grid. Yeah, predict it, then give it a color. Let me say, not blue this time. Okay, let me give it a color of green. Give it a title. These have been what we have been doing in our previous tutorials, so you do well to go back and look at those tutorials. Then I'll give it our X label. X label is the level. Then our Y label is the salary. Then we'll show what we have. plt.show. And when we run that, we see that it is almost the same with our decision tree regressor. When it's taking the step size, So this, as I said earlier in our decision tree regressor, it doesn't really adapt to a single value. Yeah, single feature. So it needs multiple features. So that wraps it up for our regression episode. In the next tutorial, in our next episode, we are going to be going into classification. We've ended this episode on regression, which ended at random forest regression. So we are going to go into classification, and classification is all about classifying data, putting it in their right categories. So just as we did in mathematics those years ago, which we learned about permutation, it's all about arranging data sets, arranging it very well. So that will be the next tutorial. So welcome to this new tutorial on our machine learning series.
basically going to look at classification, which I've explained earlier in our previous videos, that is all about categorizing classes, categorizing objects into categories. So now we are first of all going to be importing the libraries. So we have to import pandas as PD, import numpy, which is our custom importation, as MP, and we import matplotlib for our visualization as PLT, and we import scikit-learn model selection, import our train test split. Then from scikit-learn preprocessing, import our standard scalar class. Okay. Then from scikit-learn linear model, we import our logistic regression class. You have to take note of the spelling, please, so that you not run into an error. So from matplotlib colors, import our listed color map. Okay, these are the necessary things you need to import. And one more importation from scikit-learn matrix. So use it to have to import our confusion matrix and import our accuracy. So let's execute that. Is scikit-learn matrix is accuracy score. Accuracy score is accuracy score. Yeah. We'll be importing our data set. So data set to be imported is first of all, I want you to see the data set. This wine updated.csv has a series of wine based on their classification, alcohol, malic acid, ash, alkalinity. Now these values have some value. This alcohol have some values that is based on classes 1, 2, and sorry. So what we are going to be doing is now take whatever value may be in any of this column, alcohol, malic acid, ash, which are the independent variable. Predict the dependent variable, which is the class. So alcohol, malic acid, ash, which can be any of them, will be predicted based on which will be the measures of features of X variable, predicted based on the Y variable, which is the dependent variable. That's what we are going to be doing here. So import the data set pd.read csv, getting wine updated.csv. So our X value with the data set whatsoever is, I will just take 2 columns, which is just the alcohol column and then the ash column. Whatsoever be the values, y2 data set, then we pass in a class and the values in the class. So is that execute that. So we'll be splitting our data into training set and test set.
y x train, x test, y train, and a y test. So x and y, then test size should be, for the test values, should be 20% of everything. You should have random states 42. We execute that. Then we'll go into our feature scaling. We'll call our standard scalar class. It's an object. Yes, giving it a random state of 0. So what we're going to be doing is that we have to fit transform our x value, sc dot fit transform our x train values, then our s test values will be passing sc dot transform our s test values. So it's meant to, okay, this shouldn't be passed there, it should be passed in logistic regression. So we've done that for standard scalar. Then you have to train a logistic regression model. Let's call that log class equals get the logistic regression class as an object. Regression random state with 0. Then, so first of all, whatever be in a Y train, we'll have to flatten it so that we will not have a shape warning. Yes. So log class dot fit. What is it fitting is predicting based on the X train, Y train. We execute that, and that's executed perfectly. Make predictions on the test data. So we call our object log class dot predict. It's predicting whatsoever may be in the X test. Yes, in the X test. So how to predict. So we are able to predict something, and then based on our prediction, this is what the output. But we have to pass this into the variable. Let's call that y prime. So we have to evaluate the model based on our confusion matrix and accuracy score. So all that CM equal to confusion matrix, which is an object of the function confusion matrix. Then we pass in a y test and a y prime. Okay. So we are going to be printing confusion matrix. Okay. Going to be printing CM. So this is our confusion matrix value, and the confusion matrix is just a matrix of true positives and true negatives. So for this class that has three classes, 1, 2, 3, that's why it's giving us a 3 by 3 dimensional array. So it's 13 for the first column, which is 13, which is 1. The first column is 1, 2, 3, row 1, 2, 3. So 13 values correspond to true, and in that same value, only one is negative. Then for 2, 14 are true, and none are negative. Then in the third class, 4 are negative, they are not true. 1 is not true,
and 3 is true. So that is how to check for confusion matrix based on the matrix. So this is the third row and the third column. Three of them are correct. Let us see the accuracy score. Let me call this accuracy. Accuracy score, which imported. Yes. So passing the Y test, Y prep, okay, values. So we'll be printing out the values, printing out accuracy. In the formatted string, we'll just take the decimal point to be 2. Format. What is the formatting? Accuracy. Stamping it by 100 so that we can get percentage. Okay. If I execute that, the percentage which we've gotten is 83.33% as a percentage score. So that helps wrap it up for today's tutorial on logistic regression and being able to evaluate a model, check and predict the values based on the classes, categorizing them. The accuracies we have been able to get 83.3 for logistic regression. And we'll move over to the next course for visualizing our data based on the prediction we have. So, welcome to this new tutorial on our machine learning series. We are still continuing with our logistic regression tutorial, which we started in the last video. So, now we are basically going to visualize the decision boundary for our training set based on what we already have before. So, first of all, what we are going to be doing, visualizing, we're going to get a range of values for the x. First of all, call that x1 range because I'm also going to be having x2 range. So mp.arange, the start should start from the maximum value, the minimum value for x train. Yeah, so whatever be the minimum value dot mean. And so on, then it should stop on x train. As for the first value, dot maximum, then plus 1, having a step size of 0.01, okay, and x2 range. Still the same thing, but this time around, so I'll just have to basically copy this code above. Yeah, I'll copy it, paste it underneath, but this time around it's not 0, it's just 1 here. So having a step size of 0.01. So what we need to do next is that we have to create a grid of x1 and x2. Yeah. So in this range, so what we'll do is x1, x2 equal to mesh grid, mp.mesh grid, that is numpy to mesh grid. We're going to be creating a grid for that. That's x1 range and then x2 range. Okay. I'd like to execute that. So it's executed properly. So I'm going to be predicting class labels for each grid point. That's what I'm going to be doing right away. So I'll call that grid point equals mp dot concat. That is what it means to concatenate, to add both of them together.
excuse me, add both of them together. So x1 dot travel, we're going to flatten it so that we avoid shape warning. X2 dot travel, yes, then the grade predict equals call logistic regression object class predicts whatever be the values in breakpoints. Yes, then we will shape it based on the length of x1. Shape it based on x1 shape. Okay, so that is what we are going to be doing. So it's meant to be x1. It's meant to be outside the box. Okay, grid points passing in like this. Yes. So you need to take note of your brackets, please. So here we have to plot the decision points. We have to do plt.f contour f. You need to take note of all this so that you won't make mistake in your codes. X2 is projecting x1 and x2. Then grid predict and have an alpha 0.75. Then it's going to have a CMAP of listed color map. The set color map should have set color of red, and blue, and then green. These are just conventional colors that I just chose randomly. Understand? So I'm going to overlay the training data. This all plt.scatter plot. Then whatsoever be the value of x train an array of 0, then x train array in the second column. This is the first column 0, second column 1. Okay, so I'm going to get the color sc equal to y train, and then CMAP will be listed color map. So whatever is the value, it should be dark red, dark blue, and then dark green. Okay, then we should have an edge color of black, edge color K, which is black. Okay, I'm just trying to visualize the decision boundary here. So I'll give it a title. I'll call that decision boundary for the training set. And then I wanted to give it an X label for alcohol and Y label for ash. So that is basically what we predicted. Almost scale dot Y label and spelled label for the ash content. So lastly, I'm going to show my plots. plt.show. So that ran successfully. So if you look at the boundary, decision boundary for this training set, you see that not everything aligned properly. I mean, for the dark blue, the blue region and green region and red in the red region. So that's why it's having, in the last class when we evaluated the model, having an accuracy of 83.33%. So it's not very much accurate. So we don't really expect that everything should align properly, but with those what we have, we can say that it is a goal for us. So the next thing we have to do is to visualize the decision boundary for the training set. So call with the variable called you predict again, which we predict based on our logistic regression. Yes, so it will predict the grid points, which we've called the last time. It's going to reshape it to have the shape of x1. Okay, then we'll have to do what we did. So I'll only have to copy all of this. And that was copy. That was a copy. I have to copy that, paste it here. Now, only what I just need to do is just to change some values, which x train is 0 here, okay, and x. So this will run fine. So when we execute that, we can now see decision boundary. So this is meant to be S test, S test, and then S test. Okay. I just don't know what we need to change. So execute that, and then run into an error that says C has one for which is okay with X and Y values. So what we need to do is X2 predict, K predict, is predicting the test value, return test, yes, S test 0. So this is meant to be Y test and not Y train. Yeah, so that's what the problem. You need to take note of all of this so that you don't get frustrated in your code. So based on the test set, this is the visualization. Not all really aligned based on the decision boundary, so as you can see, but we have something we are working with anyway. So let me predict based on new data. I'm going to put a whole new data, then we check prediction points. So I'll call that new predict, and now passing the array of value np dot array. It's going to be a two-dimensional array. First, it's going to be, let me just choose random values. And then if you take notes, how come has a value 14, 13, 10, let's just 12, let's just put random values. Hash has 2.27. We can just choose any random value for that. So 14, 3.2. Let me just put 2.7. Yeah. Another one, 12.6. And then 3.7. Okay, 3.8. Then the last one we're going to be doing 13 points. And then let's say 2.4. These are just random values that I just choose randomly. Let's check if what we predicted and able to give us what we want. So scale new predict, going to scale it. So it's going to be called scalar. We use our sc dot transform. Basically going to transform this new scale. We transform the predict value. Then the new results will be predicted based on our log class dot predict our scaled new predict. Okay. Yeah, so that's it's going to do it. Then we'll have to print out our value. Let me see prediction for new data. Okay. So it should be passing the new results. Let's see how it works. Based on our prediction, we are able to predict that the first set of values should fall into class 1, second set should fall into class 3, the first set should fall into class 1. So that was what our system was able to predict for us. So with just this, we are being able to finish our logistic regression and classification tutorials on this machine learning series.